To Maths with Dan, and today we're looking at Pythagoras' theorem, which is a squared plus b squared equals c squared. We'll be looking at, for example, rearranging it to find different lengths of the sides of the right angle triangle, and looking at more, like, for example, harder worded questions within Pythagoras, and enjoy the rest of the video. So, starting off with the first question, we have a right angle triangle. You can see PQ is 16 centimeters, PR is 8 centimeters. Calculate the length of QR. With Pythagoras' theorem, you use it's the formula a squared plus b squared equals c squared. So this is the beginning of anything to do with sort of Pythagoras' theorem, and this is the sort of like first sort of basic question you get within Pythagoras' theorem. So a squared plus b squared equals c squared. So what you've got to do, you've got to label each side if it's A, B or C. So you always need to know that the diagonal line, which is usually the longest one, is C. So the diagonal line 16 centimeters is C, and then either of the other two, it doesn't matter, you can label it A or B. It doesn't matter which one you label it, just make sure when you put it into the formula it works out well. So plugging it into the formula, the A is 8, so you've got A squared plus B squared, which is what we're trying to find, equals C squared, which is 16 squared. You now rearrange this to then find B squared. So you put 8 onto the other side, so you got 16 squared minus 8 squared. That then gives you b squared equals 16 squared minus 8 squared. And to get rid of the square, you then need to square root what you have everything. So you square root what you have on the other side. So you get rid of that too. You've now square rooted it. Then the square root of 16 squared minus 8 squared then gives you your answer. So this is how you do it. This is how you rearrange the formula to find any sort of side. Remember how in the question it says to 2 decimal places. So you're going to have to round it to 13.86. Moving on to question 2. It's very similar to question 1, so you could give it a pause and see if you can do it yourself. If you can't, I'm just going to go through it. So I'll write out the formula again. It says XYZ is a right angle triangle. XY is 3.2 centimeters. XZ is 1.7 centimeters. It wants you to find the hypotenuse angle, so the diagonal, and because it's diagonal, you'll have to end up labeling that C. But I'll write out the formula first. A squared equals A squared plus B squared equals C squared. I just need to go over that. A squared plus B squared equals C squared. First thing you do is label the sides. Remember, like I said before, the diagonal line, the hypotenuse is C, so you label that C. And either of the other two you can label A or B. It doesn't matter which way around you do it. So you know A squared, so A is 1.7, so 1.7 squared plus 3.2 squared equals C squared. But you want to get rid of the square. You want to just find C by itself, because you just want to find, as in the question it says, you want to find YZ by itself. So you get rid of the square and you square root on the other side. And you then put that into your calculator. And you should then obtain your answer of 3.62. Moving on to a different type of question. You have a rectangular television screen, has a width was 45 centimeters and a height of 34 centimeters. It is not accurately drawn to scale, so you wouldn't be able to measure it in an exam. That would not work. It says it wants you to work out the length of the diagonal of the arc. So see that what's labelled diagonal, it wants you to find that out on the screen. It wants you to find that line, and it wants to give your answer to the nearest centimetre. So you've got to realise, because it says rectangular television screen, you know that it's a right angle. There's a right angle there, so you're able to use Pythagoras Theorem. So a squared plus b squared equals c squared. So c equals the square root, because you're getting rid of that square. 34 squared plus 45 squared. Remember the diagonal line, the hypotenuse, the one that's the longest, you label C, and the other two A or B. So 34 squared plus 45 squared. Should get as 56. To the nearest centimetre. Okay, the next one. This is slightly harder than the previous ones. You get given a trapezium, and AD, see that AD is parallel to BC, so they're running along in the same angle. Angle A is the same as angle B, which is both 90 degrees. So you know it's 90 degrees. You can use Pythagoras' theorem. You can only use Pythagoras' theorem if it's 90 degrees in a right angle triangle. AD 2.1, being 1.9 and 3.2. Work out the length of BC, which you find the bottom line. So you know AD is parallel to BC. It's told you that for a reason. So you have unlined parallel. So AD is parallel with BC. So you know, running along the same angle, so you can go down, and you know, because that's 2.1 meters, because it's parallel, you know, underneath, that can also be 2.1 meters. So you've now got like, and then you can now put 1.9 there, because they're running in the same direction. So you've now got a little triangle there, which you realise you can probably use Pythagoras' theorem on, and it wants you to find BC, and you know BC, the bottom line, is 2.1, which I've already labelled, plus x. So you now need to find x. You can find x using Pythagoras' theorem, so I'll write that out. A squared plus b squared equals c squared. You know that the diagonal line is C, it's the hypotenuse, so you can label that C, and either of the other two you can label it whatever way you want, A or B, but 1.9 is B, x is A. So you're still trying to find x, which is A. You can rearrange the formula, so x squared, which is the same as A squared, plus 1.9 squared equals C, which is 3.2, so 3.2 squared. You put 1.9 onto the other side, and you then square root it to get rid of the square. So 3.2 squared minus 1.9 squared, and it's all square rooted to then get x. when you then put that into your calculator, so you've now found the value of x, which is 2.57. So x is 2.57, but remember, BC is 2.1 plus 2.57. So you do that, put it on your calculator, 2.1 plus 2.57 is 4.67. Now this is one of the hardest sort of questions you get in Pythagoras Theorem. It's all worded. There's no sort of like diagram given to you, so you have to draw it out yourself. A ladder is 6 meters long. The ladder is placed on a horizontal ground against the vertical wall. The instructions for using a ladder state at the bottom ladder may not be closer than 1.5 meters from the bottom of the wall. So you need to construct this yourself. So you start off. So you know ladder is placed on a horizontal ground, so the bottom is the horizontal. And you know it cannot be closer than 1.5 meters. So you know if you lay the ladder down, it has to be 1.5 meters from the wall. So pretend the wall is that line on the left, so 1.5. And you know it's 6, so you're putting the ladder there, and it's going to be leaning against the wall. So it'll be leaning against that line, which is the wall. Yeah, that vertical line. So you know and the ladder is 6 meters long. So you want to see how far it reaches up. So you use Pythagoras Theorem to then work out the other angle. So remember, a squared plus b squared equals c squared. So c is the square root, because you're getting rid of the square. Six squared minus 1.5 squared. It says to 1 decimal place, so 5.8. This helped your understanding, and be sure to leave it a like. You could also reach out to me for private tuition lessons with the email in the description below, and have a good rest of your day.